Okay, so this was the assessment that we were supposed to do in the autumn term just before Christmas. Non-calculator, 45 minutes long, and it's 40 marks. So it's basically like half a paper, because a normal paper would be 80 marks, and obviously you'd get 1 hour 30 for a full paper. So this is like half a past paper. Let's go straight into it. Question 1. Circle the fraction that is equivalent to 4.625. So we've got various fractions here. These are all top heavy. These are improper fractions. There's only 1 mark, so I wouldn't go crazy and just spend ages on something like this. Probably change 4.625 as a fraction. That's the same as 4 and 0.625. So if you change 0.625 into a fraction, technically that's 625 over 1,000. Let's simplify this. What goes into these? Definitely 5 goes into these. 1, 2, 5 over 200. 5 again. That's going to be 25 over 40. And 5 again, let's do 5 again, might as well. That's going to be 5 over 8. So technically it's 4 and 5/8. So top heavy, what would that be? So you'd multiply these two together. Multiply these two together. So 4 times 8 is 32, plus 5 gives you 37 over 8, which is going to be this one. Yep, so that's your answer. Next one, circle the reciprocal of 5/6. Reciprocal, you need to know what that means. So reciprocal just means, well, you flip it upside down if it's a fraction, dead easy. So it's just going to be 6 over 5, which is that one. Dead easy. Question 3. Y equals 10 over x. If the value of x doubles, what happens to the value of y? Circle your answer. Okay. So this type of question, let's test it out. You know, if you replace the x with, let's say, let's replace it with let's call it 10. So you got 10 out of 10 for that. And then if you double x, so technically you're doubling the denominator, so that becomes 10 over 20. What does that simplify to? That's 1 whole. That simplifies to a half. So y is going to be half as big when you double the denominator. So if you double the denominator, y is going to be half as big. So technically it's going to be divided by 2, which is this one right here. Yeah. So anything like this, you know, it's a good idea just to substitute any value for x. You could have called it anything, really. Even if you doubled it, you would have seen that if you double it, it technically will halve the value of y. Let's move on. Question 4. 1/6, 1/7, 1/8, and 1/9 are 4 fractions. How many of these fractions convert to a recurring decimal? Circle your answer. Right, so, well, you should know 1/6. Pretty sure 1/6 does. Let's just check it out. So in order to check whether they do, if they are a recurring decimal, you're going to have to work them out on the side, and you do literally what it says, 1 divided by 6. So 1/6. Let's do it up here. So that means 1 over 6 is 1 divided by 6. So 1 is being divided by 6. Put a couple of zeros in there. How many 6's go into that? 0. How many 6's go into that once? Remainder 4. 6 into 40 is 6. remainder 4. Oh, there you go, 6, remainder 4, 6, remainder 4, and so on. Yep, so that's definitely recurring fraction. Recurring decimal, sorry. 1/7, let's try that. 1 divided by 7. Let's try it out. 7 into 1 doesn't go. 7 into 10 goes once, remainder 3. 7 to 30 goes 4 times, remainder 2. Might need a few zeros for this. 7 into 20 goes twice, remainder 6. 7 to 60 goes 8 times. Remainder 4. Are we repeating ourselves yet? No, we need to keep going. 7 into 40 goes 5, remainder 5. 7 into 5, blimey, this one's pretty big. Let's keep going. 7 into 50 goes 7, remainder 1. Now we're repeating ourselves. When we do this, 7 into 10 goes once, remainder 3. Yeah, now we're repeating ourselves. So it's going to be, that's definitely a recurring decimal. Yeah. 1/8, I don't think that's a recurring decimal. Let's check it. 1/8 is 1 divided by 8. Let's try it out. 8 into 1 doesn't go. 8 into 10 goes once, remainder 2. 8 into 20 is twice, remainder 4. 8 into 40 goes 5 times exactly. Yeah, that's not a recurring decimal, so 1/8 definitely is not a recurring decimal. 1/9, I'm pretty sure 1/9 is, I'll show you here. So that's 1 divided by 9. 9 into 1 doesn't go. 9 into 10 goes around 1, remainder 1, 1 remainder 1, 1 remainder 1, and so on. Yeah, that's definitely recurring. So the only one that wasn't recurring is 1/8. So how many of these fractions convert to a recurring decimal? 1, 2, 3. Definitely 3. Again, just 1 mark. You don't want to spend ages on something like this. Let's move on though. Question 5. The next term of a sequence is made by adding the previous 2 terms. Which of these sequences follows this rule? So this sounds like Fibonacci sequence. Yeah, you add the previous 2 terms. Which of these sequences follow this rule? So let's check them. So -9 plus 2. If you're adding 2, it's getting warmer. Yeah, that works. So -7, you do get that. When you add 2 to -7, you get -5. Yeah, again, that's right. And then -5 add -7, you get -12. It's getting colder. Yeah, -5, -7, -5. Yeah, that's right. So that one, already I think we found our answer. Let's check the other ones. -3 plus 5. That's getting warmer. So you're on -3. If you're going to add 5, that's going to be +2. So they've got -2, so definitely not -2. That's not right. Let's check this one. 0 add -3 is obviously -3. -3 add -3. No, that's not right either. So that should have been -6 here. So that's not right. -1 add -1 is -2. That's right. -1 add -1. -1 add -2 gives you -3. Yeah, that's right. -2 add -3. That's getting colder. So that's not right either. So the only one that's correct. Oh, it's a funny circle. This one right here. Yeah, so you should circle that one. It's always worth checking the other ones, but definitely that first one was definitely following a Fibonacci sequence. Yeah, if you're not sure, do use the number line to help you. And don't forget those rules about negative numbers. Let's move on. Question 6, work out the cube root of 64 times by 1000. Circle your answer. One of these, yeah, basically the cube root is, you can basically do it to both those numbers there. So what's the cube root of 64? You should know that. It's the opposite of cube. Obviously, if you know your cube numbers, you're going to know your cube root numbers as well. So something times something times something gives you that 64. It's going to be 4. That's the cube root of 64. And that's going to be 10 for the cube root of 1000. Yeah, 10 times 10 times 10 gives you 1000. So the cube root's got to be a 10 for that. So you're left with 4 times 10, which is 40. So it's definitely that one. Done.
Question 7. Short side of a parallelogram has side 6.5 centimeters. Yeah, okay, yeah, we can see that. Length of the short side is 1/9 of the perimeter. Work out the length of the longer side, which is this bit here, isn't it? Yeah, so that's the longer side, which is the same as that. And the shorter side, which is that, is the same as that as well, isn't it? Yep, the perimeter means going all the way round. So if the shorter side is 1/9 of the perimeter, let's write this down. Shorter side equals 1/9 of P, let's call P the perimeter. So if you get rid of the fraction, you're going to have to times by 9 to this side. And you're going to have to times this by 9 as well. So that'll be P equals whatever the shorter side times by 9 is. So that's 6.5 times by 9. So this is without the calculator, so you're going to have to work out on the side. Let's do it this way. So 5 times 9 is 45. Put the 5, carry the 4. 6 9s are 54, plus the 4 is 58. And you've got one decimal place altogether. So P is 58.5 centimeters. Okay, so that's the perimeter. And we said perimeter is all the way around, so it's 2 L's plus these two. So P equals 2L plus 6.5 plus 6.5. We know P is now 58.5. 2L is just 2L for the time being. 6.5 plus 6.5 is 13. So I'm going to have to take away 13 to both sides. Let's do, I'll tell you what, let's do 58.5. Take away 13. I have to do it like this. 5 take away 0 is 5. 8 take away 3 is 5. 5 take away 1 is 4. That's 45.5. Okay. We just want one length. So you're going to have to divide that by 2. Let's do the bus stop method here. 2 into 4 goes twice. 2 into 5 goes twice, remainder 1. 2 into 5 is 7, remainder 1. 2 into 10 is 5, so it's 22.75. Yep, that should be your final answer. 3 marks. Let's move on to the next one.
Question 8. Multiply out and simplify 2 marks. So this literally means, if it's got a square on it, it just means x minus 8 multiplied by itself. Yeah. Let's do it step by step. This one with this one gives you x squared. This one with this one gives you minus 8x. This one with this one, another minus 8x. this one with this one. Negative times a negative is going to give you a positive. 8 times 8 is 64. Yeah. And simplify it. This goes with this. Oh, that was a funny one. Should we do that? It's a bit weird using this pen. And so you've got x squared minus 8x minus another 8x, that gives you minus 16x. Yeah, it's getting colder. Plus 64 on the end. 2 marks for that. Let's move on. Factorize fully. Factorize just means put it back into brackets. So, what's the biggest number that we can take out? 3 definitely. Biggest value of y we can take out is just 1y. What you're left with, that's going to give you 3y squared minus, if you're not sure, let's just do it this way. So I've got minus 6y. It's being divided by 3y. So what does that give us? This cancels with this to give you minus 2. That cancels with that. So yeah, you're just left with minus 2 on the end of that. If you expand this, you should get the original. Let's just double check that with that. Yeah, 3 times 3 gives you 9. That's that bit there. Y times by y squared gives you y to the power 3. Yeah, that bit's right. And then 3y times minus 2 gives you minus 6y. Yeah, so that's your answer. 2 marks for that. If you're not sure, just work it out on the side. And obviously the opposite of multiplying is dividing. You're going to have to divide by this on the from the outside. And you could work it out like that as well. Factorize this. Definitely double brackets. Bit of a tricky one this, because we've got a x squared that's greater than 1. You could do it straight from that and just give the answer. Shall I do it that way? Yeah, might as well. You could do, or I could do it the long way. Let's do it the long way. Might as well show you guys, because it's, some people can just go straight into the answer, because I know it's going to be 3x in one bracket and x in the other anyway. Let's do that. I'll show you both ways. So obviously it's going to be double brackets, 3x here and x in this one. Obviously it makes no difference which order this is in. You could have had the x here and 3x in this one, but you're still going to get 3x squared when you multiply this out, so it has to be 3x here and x here. And obviously we've got a plus 7 as well, so which two numbers multiply to give you that? Well, 1 and a 7. Right, so if I put, let's say I put a 1 here and a 7 here, and it's positive 7. So they could either be both positive or both negative. I think they're both going to be negative because I've got a negative 22 here. Let's see what happens when I do this. If I expand this, that gives me minus x, these two together. Yeah, that gives me minus x. And then these two together, it's going to give me minus 21x. So yeah, there's your answer. Got my answer straight away. So you could do a little bit of trial and error. I wasn't too sure actually to begin with. I could have done 7 here and 1 here. Let's see if we get the same. We don't get the same. No. This gives you minus 7x here and minus 3x here. So altogether I get minus 10x, which is not the same as that obviously. So it has to be the other way around. It's got to be a minus 1 here and a minus 7 here, so it's got to be this way around. Yeah, it can't be anything else. There's your answer. If you're not sure, If you want to do it the long way, then you can. I can show you the long way. It's called the AC method. That's because you multiply these two together. That's your A, that's your C. Multiply those two first. So 3 times 7 gives you 21. It's positive 21. And that is made up of two numbers that also equal the minus 22 at the same time. So two numbers that multiply to give you 21 and also add to give you minus 22. So it has to be minus 21 and a minus 1. Yeah, if you multiply these two together, it gives you positive 21. And when you add these together, you'll get minus 22 as well. So this minus 22, let me just read this out. It's a little bit complicated, but basically you split this minus 22x into minus 21x, which is that bit, and minus x, which is that bit. Yep, you've still got a plus 7 on the end here. You've still got 3x squared here as well. Yep. Now we've got to factorize this bit. Factorize this bit separately. Yeah. So when we factorize this, what can we take out? We can take out 3, definitely. And we can take out an x. What are you left with? You're left with x minus 7. Yep. And when we factorize this bit, we should get the same in the brackets as well. But the only way to get the same brackets is if we take out a minus 1. So if we factorize this, take out minus 1, what are you left with? X minus 7. Yeah, so you do get the same brackets. See, if there's two brackets, should be the same. So that's one of your brackets. And the other brackets is the other two values here, the 3x and the minus 1. That's one brackets, 3x minus 1, they go together. And the other brackets is one of these, x minus 7. There's your answer again. Yeah, so you could do it that way. That's the long way of doing it. The quick way was just going straight into the brackets, the two brackets, and it's definitely going to be 3x here and x here. It can't be anything else. You know, and just trying to figure out the others. There's a little bit of lateral thinking going on here. That's probably the best way of explaining how to do that. But if you can't do lateral thinking, then you can just do it the long way, which is a little bit complicated. But if you know this method, it's called the AC method. Maybe have a look at that if you're not sure. Yep. Let's move on. Question 10, write down the value of 7 to the power 0. Well, anything to the power 0 is just 1. Yeah, you just have to remember that. It's one of those questions. It's one of those questions that a lot of people do get wrong, and they think, oh, it's got to be 0, or it's going to be 7, or some other answer. Completely wrong. You know, always just think of the power 0 as 1. Yep, it's part of your power rules, right? Part B, work out the value of 32 to the power minus 3/5. Well, okay. Well, anything to the power minus power or negative power, sorry, is going to be a reciprocal or 1 over the amount. So it's going to be the same as 32. No, in fact, it's the same as. Let's split this up. In fact, let's split it into 32. And then your power goes here. Let's split these powers into what it's made of. So technically, it's the same as 3 times 1/5. Yeah, that's the same as 3/5, isn't it? Or minus 3/5. Okay, let's put a minus there then. So that's the same as 1 over 32 to the power 3 times 1/5. Okay, which is 1 over 32. Power fifth means the fifth root, so that's going to be the fifth root of 32. So that's going to be the fifth root. Let's put a little 5 there, and you've still got the power 3 there as well. Let's work out the fifth root of 32. So what does that actually mean, the fifth root? So something times something times something times something times something gives you 32. You'd have to go up in your let's start with the 2 times table. What is 2 times 2 times 2 times 2 times 2? 4, 5. Does that actually equal 32? Let's check. 2 times 2 is 4, 8, 16 is 32. Yeah. So the fifth root of 32 is technically 2, and you still got power 3 on the outside. So it's going to be the 1 over 2 times 2 times 2, which is 8. Yep, so that's going to be 1 over 8 as your answer. Bit of a weird one. It's got a negative power in there, and it's got a fractional power, so it's a bit of a 2-in-1, this one. So you're going to have to break it down. Obviously, the negative power just means it's going to be a reciprocal, so it's going to be 1 over the original number, whatever it was. And just work out step by step. And break that fraction up into what it's made of, and just do it step by step. Yep. Next one. Question 11. Joe and Kyle share an amount of money in the ratio 7 to n. Joe gets 35% of the money. Work out the value of n. Right. Okay, so Joe and Kyle share an amount of money in the ratio 7 to n. So if Joe gets 35% of the money, Kyle must get the rest, which is 100 minus 35, which is 65%. So if it's in the ratio 7 to something, we can definitely put this as a ratio. Joe and Kyle, let's put it in the ratio. Let's do it in percentage instead first. Let's see. So if it's Joe gets 35%, Kyle gets 65%, and we want it 7 to something. Why is that something? How do you get from 35 to 7? Well, you have to divide it by 5. Let's divide this side by 5 as well. How many 5s go into that? You can do it on the side if you're not sure. It's going to be 13, isn't it? Yep, so n is going to be 13. There you go. There's your answer. So n equals 13. That's what it's asking for. 2 marks just for that. That's fine. Yeah, just work out step by step. You know it's going to be Joe to Kyle. That's going to be the ratio, isn't it, from Joe to Kyle? We know that Joe has 35%. Kyle must have the rest, which is 65%. And just simplify it. You know, you'll get your answer 7 to something. What is that something going to be? That's what it's asking for. And just do it step by step. Yep. Question 12. Billy wants to buy these tickets for a show. 4 adult tickets at £15 each. 2 child tickets at £10 each. 10% booking fees added to the ticket price. Okay, 3% is then added for paying by credit card. Work out the total charge for these tickets when paying by credit card. 5 marks for this. Wow. Yeah, well, because we haven't got a calculator, that's why, isn't it? It's a lot of working out. Let's see. So Billy wants to buy these tickets for a show. 4 adult tickets at £15 each. 2 child tickets at £10 each. Right. 10% booking fees added. Right. 3% is then added. Okay. Let's work out how much it would be. 4 adult tickets, £15 each. Let's do that first. that's going to be 20. Carry the 2, that's going to be 4. Plus the 2 gives you 6, that's going to be £60 for the adult tickets. Okay. Then we've got 2 times 10 for the child tickets. Okay. 10%, so, okay. Right. Right. So a 10% booking fee is added. And then 3% is then added. Right. So we need to do the 3% at the end. Okay. So we have to do the 10% first and then the 3%. So you have to do it in that order. So let's do the total first. So the total is going to be 60 plus 20, which is £80. That's without the booking fee and everything. Yeah. So 10% of that, 10% of 80 is going to be £8. Yeah, in fact, should we show the working out? That's obvious, but might as well. Yeah, 10% is going to be £8. Okay, which is added on, obviously. So now it's going to be total with booking fee. Which is £88. Okay, and now the 3% is added on, right? So 3% of this, and we'll do that without a calculator. Let's work out 1% first. So what's 1% going to be? 88 divided by 100, which is 0.88. So it's 88 pence, isn't it, technically? So 3% would be 3 times that. Let's do it this way. 8 3 is 24. Carry the 2. 24 again plus 2 is 26. Oh, shouldn't have done that. Not yet, anyway. What's next? It's 0 plus 2 is 2. Right. I got 2 decimal places here. 0 here. So altogether you've got 2 decimal places. So yeah, it is actually there. But yeah, it's worth checking where your decimal place actually goes. It's not always the case, but it's worth checking how many decimal places you've got in total. £2.64. Work out the total charge for these tickets when paying by credit card. Yes, the total charge is going to be all of it added together, isn't it? So it's going to be 88 plus £2.64, which is £90 and 64 pence. Yep, there's your answer. £5. Question 13. Circle the inequality shown by the diagram. Right, well, if it's an empty circle, that means it's not included. And filled in circle means it is included. Now you got x, values of x in between. So, not that one, not that one, not that one. It's got to be this one. Yep, not included, included. Yep, it's definitely this one. There's your answer. Yep, so these, you do need to know what these circles mean, yeah. So if it's an empty circle, that means it's not included. So there's no line underneath this one. And if it's filled in, it is included, so there's a line underneath that one. Yeah. Question 14. A is the point 2 minus 5. B is the point 4 minus 9. Show that the gradient of the straight line passing through A and B is minus 2. Well, yeah, we've done gradient before. So gradient is change in y over change in x. So what is the change in? Well, that's my x, that's my y. So we can do, just be careful with these negative numbers. Let's do, I'll tell you what, let's do minus 9 minus 5. Yeah, because it's the difference between them. Let's put the minus 5 in brackets. So it's got to be a minus here because obviously it's the difference between them. We'll come to that in a minute. And I've got to do it in the same order for my x as well. So I've got to do 4 take away 2. Yeah. Let's do the top bit first. So I'm on minus 9. I'm on minus 9 on the number line. Well, a minus and a minus here gives me a plus. So technically it's minus 9 plus 5. So it's getting warmer. So minus 9 plus 5, if it's getting warmer, I get minus 4 for my numerator. And obviously 4 take away 2 is 2. Yeah, and this simplifies to minus 2. There's your answer. Yeah, so show that the gradient is that. Yeah, and it is. 2 marks. Part C says, C is the point minus 301 to 601. Does C lie on the straight line passing through A and B? You must show your working. So this is a link to previous information. Let's see. Does C lie on the straight line passing through A and B? So if it goes through the same line, then must have the same gradient. So we have to have, it's going to be the same gradient as this, definitely, minus 2. So we can use y equals mx plus c, yeah, for any straight line. So we know it's going to be, m is the gradient, we know it's going to be minus 2x plus c. Don't know what c is. Or do we? Actually, let's double check. Tell you what, let's use these points definitely go through the lines. Let's use A as our reference. So we've got x equal to 2, y equal to minus 5. So let's use, what's it? 2 minus 5. Let's use that first to work out C. I'm going to have to substitute these values in. So I've got minus 5 equals minus 2 times x, which is 2, and c, which is what we're trying to work out first. So that is minus 5 minus 4 plus c. Add 4 to both sides, you get minus 1 equal to, so c is minus 1. So technically you've got the equation of the line as, what's that? Right. So if this point is on the line, then it should satisfy this equation with the same gradient. Yeah. So if we put, let's use minus 301, 601. So that's my x, that's my y. Let's substitute in these values. So I've got 601 equals minus 2 times minus 301 minus 1. That's obviously still the same. Minus 2 times this gives you positive, definitely positive, 602 minus 1. So yeah, 601 is equal to 601. It does. So it does satisfy. It does satisfy this this line, so definitely. Yeah. Does C lie on the straight line passing A and B? Yes. It does. Question 15. In a chess club, there are X boys and Y girls. If 5 more boys and 8 more girls joined, there would be half as many boys as girls. Show that y equals 2x plus 2. 2 marks. Okay, so let's write what we know. So boys, we got x number of boys, and for girls is equal to y. Okay, so if 5 more boys were added, so it's x plus 5, and 8 more girls were to join, so that's going to be y plus 8. Okay, there'll be half as many boys as girls. Okay, so these guys, they're going to be half as big as girls. So we need, for them to be equal, you're going to have to double the number of boys. So you're going to have to do twice as many boys should equal how many girls we've got, which is that. Yeah, show that this show that y equals 2x plus 2. So if we rearrange this, hopefully we should get y equal 2x plus 2. Let's see. So let's expand this. So we've got 2x plus 10 equals this. Let's bring everything to the same side. In fact, I need to put. So let's switch it. In fact, so let's put y on this side. Yeah, it's the same thing anyway, isn't it? Yeah. So now, if I minus 8 to both sides, I will get 2x plus 2. There you go. Yep. And you've shown it. That's your answer. That's part A done. Part B. If instead 10 more boys and 1 more girl join, there would be the same number of boys and girls. Work out x and y. Okay. So, if instead 10 more boys and 1 more girl join, there will be the same number of boys and girls. Right. Okay. So let's write this thing again. So instead, so we've still got, originally it was that and that. So if instead 10 more boys join, so we're going to get x plus 10, and 1 more girl is going to give you that. There would be the same number of boys and girls. Right, so now you've got x plus 10 equals y plus 1. Okay, let's compare this to the other equation. So I reckon we're going to get simultaneous equations. Let's make y the subject. So I'm going to minus 1 to both sides. So I'm going to get x plus 9 equals y. Okay, let's call this equation 1. And I've got the other equation from part A, which is this one, y equals 2x plus 2. Let's call that equation 2. Yeah, let's use simultaneous equations. I'll tell you what, you know what? If y equals this and y equals this, let's just replace y with one of these. So I'm going to combine equation 1 with equation 2. Yeah, so that must mean x plus 9 must equal 2x plus 2. Let's solve what x is first. So let's take away x to both sides. I'll get that. Just to show you guys what I'm doing, I'm taking x from both sides. Yeah, that gives you that. And now let's minus 2 to both sides. That's going to give me 7 equals x, or x equals 7. There's your first answer. So x equals 7. Now let's put that back into any of these equations. Let's put it back into the first one. Let's put it back into equation 1. So that gives 7 plus 9 equals y. So 7 plus 9, which is 16. So y is going to be 16. Yeah, there's your two answers. Question 16. Show that 14 over root 7 can be written in the form a root b, where a and b are integers. Right, so 2 marks. We've seen this type of question before. So if you have anything like this, it wants you to change this into something that looks like this. The only way to do that is by rationalizing the denominator. So you have to multiply this by what the denominator is. So you've got root 7 over root 7. Yeah, I'll multiply this out, so you'll get 14 root 7 at the top over root 7 times root 7 is just 7 on its own. Yeah, so the roots cancel each other out. So you'll just get 7 there. And then we can simplify this. How many 7s go into 14? 7 goes to that once. 7 goes to the 14 twice. So you should get your answer 2 root 7. Yeah, and you've got it in that form, a root b. That's your answer for part A. Part B, work out 2 root 10 times root 80 times root 18. Give your answer as an integer. 3 marks. Okay. This type of question, I like to break it down into other roots that it's made up of. So let's just write this down as it is. I can do this in any order, makes no difference. And break it down into other surds. So 2 root 10 is the same as 2 root 5 root 2, okay, times, what's the biggest square number that goes into 80? Does 16 go into 80? Let's just double check. How many 5s go into 80? Let's just double check something. I just want to check something. 5 goes to that once. Yeah, 16. So, you know what? I'm going to change root 80 into root 16, which can be simplified even further in a minute, which I'll show you. And root 5. Okay. And what's the biggest square number that goes into 18? That's going to be 9. Yes, we can call that root 9 root 2. Okay, and let's simplify even further. So that's going to give me, still got that, still got that, still got that. Okay, can't do anything about that. That's going to give me 4 root 5. That's going to give me 3 root 2. Okay, let's bring these together. So I can bring a couple of these together. So I've got 2 times 4 times 3. Okay, so that's that, and that done. Root 5 times root 5, that's going to give me just 5 on its own. That's that and that done. And I've got root 2 times root 2, which gives me just 2 on its own. That's that and that done. So if I just work this out, this should give me my final answer. Let's do it in stages. Let's do 2 times 4, which is 8. 3 times 5, which is 15, times by 2. So technically, it is 8 times 30, which gives me 8 times 3 is 24. Add a 0 on. You're going to get 240 as your answer. So yeah, that's a really good way of doing it. You know, there are other ways as well, but me personally, I like to break it down into other surds like this. Just break it down, and you can just collect like terms, you know, like how you collect like terms for algebra. Very, very similar, and you'll eventually get your simplified answer in no time, you know, by doing it that way. So it's a really good way of doing it. Initially, though, what I was looking for was the biggest square number that goes into these numbers, and you can just simplify those a lot quicker. So that's the idea behind it. Okay, that was the last question. Hope you found it useful. In the next video, I'm going to go through the second paper, paper 2, calculator 1, for the autumn mock paper.